All right, here we go. We are, again, in Chapter 7, Section 2, Division Properties of Exponents, continued. And we're going to start with the power of a quotient. Right, the power of a quotient. So this is very much like the power of a property, or power of a product, where in this particular problem, I've got the letter x divided by the letter y, and then we're going to raise that to some power m. Right? So from here, we simply give that power to everything inside my quotient. And so this turns out to be x raised to the power of m divided by y to the power of m. Not a very complicated property. I do want to kind of illustrate exactly what happens with this one. When we take a look at 3 over 5, or 3/5 raised to the power of 3, we could, of course, turn that into what it actually means, which is 3 over 5 times 3 over 5 times 3 over 5. And then, of course, we could multiply all straight across the top, and then multiply straight across the bottom. When I do so, what do I get? If I do 3 times 3 times 3, what do I get?
27.
I get 27. And on the bottom, as was just stated, we get 125. Right? Now, of course, we can also use our new property to turn this into 3 raised to the third power and 5 raised to the third power, which will still give you the same answer, 27 over 125. Right? So that's kind of what's happening with this particular property. All right. So let's play with a slightly more interesting one. 3p to the third power divided by 7, all raised to the second power. So with this particular problem, if I show my work here, I have 3 to the second power, and then we have p to the third power to the second power, and it's going to be all over 7 to the second power. It's a 7, because that's the letter P. I can see your confusion, though. So from here, we can simplify that down. 3 squared, of course, is 9. And P cubed squared is?
49.
Nope. P to the 6th. And 7 squared is 49. Details, details. All right. Make sense?
Yeah.
All right, we are about to embark on one of the most difficult properties you will ever play with in this class.
0. No, it's like E.
0 exponent property.
No.
Now, this one is supremely difficult. I would be surprised if you've heard of it before. But does anyone think they know what happens when you raise something to the power of 0? Yes, Miss Neely?
Isn't it like 0?
No, I can understand why you would say 0. Like, I get it, but it's not 0. Right?
Is it 1?
It is indeed 1. Right? When you raise something to the power of 0, you get 1. Right? So, what we are about to write down is the following phrase. Anything to the power of 0 is 1. Sorry, did you want to try again? Anything to the power of 0 is 1. Right? So, let's get this written down here. Thank you, Miss Ledbetter, for that impromptu joint teaching session. All right. Anything to the power of 0 is 1. Except 0. We don't talk about raising 0 to the power of 0. It just doesn't work. So anything except 0 can be raised to the power of 0 and give you 1. All right. So let's try a little problem here. So the deal here with this is that I wanted to kind of show you exactly why this works. Because I can understand why you would think that something raised to the power of 0 would give you 0. It sort of makes a little bit of sense. But if we take a look at exactly what happens here, I think you'll see why this turns it into 1. So let's expand 5 to the third power. That gives me 5 times 5 times 5. And then expanding 5 to the third power gives me 5 times 5 times 5. And we can start to reduce. And if I reduce the 5 and the 5, they both go to 1, right? If I reduce, I can divide both 5 and 5 by 5, and they become 1. All right, each one becomes a 1. And then I can reduce there, 5 and the 5, they both become 1. And then this 5 and this 5 also become 1. And then if I multiply across the top, I get 1. And if I multiply across the bottom, I get 1. And if I reduce, I get 1. Does that make sense? Okay? So, if I use my power, or my division property of exponents, then I can also turn this into 5 to the power of 3 minus 3. Because when you divide with powers, with exponents, you get to subtract the exponents. And so that turns that into 5 to the 0 power. And since we started with one thing, right? Since we started with one thing, and I got a 1, and then I started with that same thing and got 5 to the power of 0, then both of those must be equal to each other. So 5 to the power of 0 must be equal to 1. And so a brief explanation or reason for why raising something to the 0 power is 1. All right, let's try this problem. Let's kind of work this out here. So first things first, I have division, x to the 5th divided by x cubed, means that I will take the 5 and subtract a 3, and then I've got that y to the power of 0. So what happens with my x squareds? Let's try that again. What happens with x to the 5th minus 3? I get x squared. Sorry, I said the answer as I was asking the question. What happens with y to the 0?
Y.
It stays
1.
1. It becomes a 1. It doesn't mean that I have a y left over. It means that this whole thing, this whole y to the 0, right, becomes just a 1, right? And so that's my answer. I'm done right there. I don't need to write the 1. You can. I won't count it wrong. I might roll my eyes a little bit, but I won't count it wrong. But you definitely don't need to write it. All right. So let's go with a slightly more complicated one. So negative 4 times n squared times q to the 5th times r squared, all divided by 9 n to the 3rd power q to the 2nd power r. Oh, and then I almost forgot. Let's raise the whole thing to a power. What do I get? Yep, I just get 1. All right. No matter how complicated that is, the whole thing was raised to the power of 0. Because the whole thing is raised to the power of 0, we just get 1. So, negative exponents. These are my favorite. So negative exponents, there are a couple of things that we need to make very clear right up front. A negative exponent does absolutely nothing for the sign of the power. Okay? A negative exponent doesn't change signs. And we'll talk more about it when we come back. Okay, so the thing I need you to know about negative exponents is that negative exponents do not do anything about the sign of whatever it is that we're dealing with. So it's important that you understand that x raised to the negative third power is not equal to negative x raised to the third power. Those two things are not the same. Not in any way, shape, or form are those the same. What a negative exponent does, as in x raised to the negative m power, is it changes its location in a fraction. And so that becomes 1 over x to the power of m. So when you have a negative exponent, we take a look at where it's at in a fraction and we change its location. And once we put it in the right place, then the sign becomes positive and everything is back to normal. Now, to illustrate why that works this way, I have this little problem. And so we've got 3 squared and 3 to the 5th, and let's go ahead and expand that out, giving me 3 times 3 and 3 times 3 times 3 times 3 times 3. So, of course, my first set of 3's will cancel out. My second set of 3's will cancel out. And I am left with 1 over 3 to the third power, because there are 3 3's. Well, using the division property of exponents, we can also turn this into 3 to the power of 2 minus 5. And 2 minus 5 will give me negative 3. And since those two things are set equal to the same thing, then they must also be equal to each other. So 3 to the negative 3 power must be the same as 1 over 3 to the third power. So here is kind of what I need you to make sure that you understand when it comes to exponents and being negative. A negative exponent says that the power is in the wrong place in a fraction. Again, a negative exponent says the power is in the wrong place in a fraction. So if I have a negative exponent and it's on top of a fraction, where does it belong? I'll try that again. If I have a negative exponent and it's in the top of a fraction, where does it belong? On the bottom. Right? You guys can just say it out loud. It's okay. Right? If I have a negative exponent and it's on the bottom, then it belongs on the top. Right? So it doesn't flip the entire thing. It only moves the one thing with that negative power. Right? So let's try this problem here. We have 5 r to the negative third, t to the fourth, and then negative 20, r squared, t to the 7th, and u to the negative 5th power. Now again, I want to impress upon you that having a negative number does not mean that it gets a negative exponent. So the negative 20 in this problem, it's going to stay negative. It doesn't mean that I move the 20 to the top. It doesn't mean anything like that, right? You'd be surprised. I'll see that on the test, I'm sure, right? But it does not mean that. So let's go through this and start to play with this problem. What can I do with the 5 and the negative 20? I can reduce, right? So the 5 becomes a 1 and the 20 becomes a 4, and it's still negative, right? So I know that I am going to have a fraction that has a 1 on top, a 4 on bottom. I like to put my negative either out front or on top. I think it looks weird if it sits on the bottom, so I'm going to attach it to the top. Now the next thing that I want to do is play with the negatives. I want to fix where they're at. So we're going to go in and find the 2 negative powers that I've got. I've got r to the negative third power and u to the negative fifth power. And what that does for me is it simply takes the first one and moves it to the bottom. So on bottom I now have an r cubed. Right? The t to the fourth is still positive, so it stays on top. T to the fourth. Now on the bottom I have an r squared. It's positive. It stays where it's at. I have a t to the seventh. It's positive. It stays where it's at. But then I have a u to the fifth, negative fifth, and it needs to move to the top. And so we wind up with u to the fifth power on top. So you can see how things have moved. All right, now I am going to deal with multiplication or division. I'm going to get rid of the negative 1 and just attach that to the t there. And so what I have now is negative, and then I've got some multiplication and division that I can do. So I'll start with the division. I have a t to the fourth and a t to the seventh. That is division, and so what I have now is t raised to the 4 minus 7 power. The u to the fifth, there's nothing to do there, so it just stays u to the fifth. There's no u on the bottom to divide with. When I go to the bottom, I've got that 4 sitting there, but then I have this last bit of problem to play with. This is r to the third times r squared, and so that means that on the bottom I have r to the 3 plus 2 power. And so if we finish off all of these pieces, then we wind up with a negative t to the negative third power, u to the fifth, all over 4r to the fifth. Now, of course, we have one last negative exponent to take care of, and so moving that to its proper location will give me my final answer of negative u to the fifth, all over 4r to the fifth, t to the third. Now again, I realize I've shown a lot of work up here, and I know that as you guys work your own problems, you probably will not show that much work, and that's fine. But in your notes, I feel like it's important that you can see everything that's happening, right? So that when you come back to your notes, because that's why you take notes, is so that you can come back to them and look at them and figure out what's happening when you have forgotten. So, we've already been given a list of what happens when you simplify with exponents, but now that we've talked about negative exponents, I felt like it was time to update that list. So, when you simplify with exponents, number one, you should only have positive exponents. I don't know why it skipped so far, but number one, you should only have positive exponents. Number two, each exponent should only appear once. Each exponent should only appear once. So again, this is what needs to happen every time that you simplify and there are exponents involved in the problem. The first thing that needs to happen is there needs to be no negative exponents in your simplified version. It should only be positive exponents. Number two, each base should only appear once. There should be no power of a power. So we shouldn't have any parentheses with a power on the inside and a power on the outside. We need to fix those. And then here, last but not least, we have number 4, all fractions should be in their simplest form. So any number should be reduced down as far as it will go. All right, let's try one last little problem. We'll run through this one relatively quickly. I won't show quite as much work on this one. So, n to the negative fifth, p to the fourth, r to the negative second, p squared, and then the whole thing being raised to the second power. We can start with moving any of my negative exponents. And so I've got p to the fourth on top and an r squared. On the bottom, we have a p squared and an n to the fifth. And then the whole thing is still being raised to the second power. I'm going to go ahead and do my division. And so I have a p to the fourth on top. I have a p squared on bottom. And so I will take that 4, subtract that 2, and get my new problem, which is p squared r squared all over n to the fifth, the whole thing being raised to the second power. Next step is to raise everything to that second power. And so we wind up with our final answer of p to the fourth, r to the fourth, all over n to the 10th. Make sense? All right, your homework is here. We have page 402, 9 through 17, all of them, and then 23 to 41, the odds.